I'm John Bogovic. I'm part of the Solid Lab at Janelia, and I'm going to be talking today about its proposals for coordinate systems and transformations in OME-Zarr. This is a technical topic, but it won't be a technical. So if you want the nitty-gritty details, I'll have a poster this evening. So talk to me about them there, or really anything else. And doesn't be a poster. So I'd like to start by reflecting on some of the goals of the project in this community. Yep.
You try to close the Zoom window because we can see only half the slides.
Yeah. That's
And the thing will go away in a minute,
yeah, great.
mostly.
Thank you. I'm going to start by just reflecting on the goals of this community and some of the successes of this community and project. So fair data sharing and software interoperability are important to all of us, I think. And one of the places that I think OME-Zarr has been very successful is in its multi-scale specification. Here's a familiar face talking about a problem and a solution. Long ago, it's useful to store the same image at different resolutions. It's useful for viewers so that, for example, a viewer can quickly load and display a low resolution while the higher resolution data are being loaded. But long ago, different viewers had different expectations about how the metadata and the formatting of these different resolutions were just displayed in metadata. And this is anathema to interoperability. And OME-Zarr said, let's just write things down and agree on how to write things down. And this enables standardized access of the same image data across different viewers so that your favorite viewers can interact with, display, and process the same data without copying. And without copying is really important if the data are enormous, as data are becoming. And so something I want to emphasize first is that this is really not technically difficult, but the challenge is in a sociological one, basically. How do we agree on how to write stuff down? And one of the things that multiscales does is describe a relationship between the different scale levels that I'm showing here. I can use this, right? Yeah, the different scale levels here and some physical coordinate system. And what I'm going to call is the blue stuff are coordinate systems, and the green arrows are the coordinate transformations that describe the relationships between these things. But we might want to explain what other relations between other objects, like this other image and this image. For example, can we know whether this point in this image corresponds to any other point in this image or not? And the answer today is you just have to know, but there's not a way for the metadata to communicate that to another person or a computer. Especially important for the problem of image registration. So given two images, image registration is the process by which you generate a coordinate transformation, such that when you apply that coordinate transform to one image, moving image, the result is aligned to the target image. And here aligned means that the same point corresponds to the same thing, like the same anatomy, for example. But it doesn't have to be exactly the same. For example, two channels of a multi-channel image would be in the same coordinate system, right? And the two scales of a scale pyramid might be in the same coordinate system after you've transformed them to the physical coordinates, right? So I use a lot of registration algorithms, and I'm a fan of a lot of them. And the main output is the coordinate transformation. Do you think their outputs are similar? The answer is no, of course not. My favorites, detail aren't important, but like these contain roughly the same information, but they're totally different. This is unsurprising because if we work alone, we make different decisions. And this reflects, this is the same problem that we faced with multi-scale images, right? And this is one of the problems that we'd like to solve for the image registration problem. So I'm a user of image registration algorithms, and I'd like different libraries to interoperate. I also have a personal stake in this because I wrote and maintain an image registration library called Big Work. So here you're seeing me click some points to better align these images. And as a software developer, I'll just let this play, but as a software developer, I need to export transformations, and I would also like to import transformations from other software so that this can interoperate with them. And right now, it's difficult for me to know how to export these transformations. So this is how this started, but this is a list, an incomplete list of other headaches that I have that essentially relate to knowing what coordinate system something is in. For example, like a really common problem I have is someone will give me like an annotation, like point annotations, and I always have to ask, is this in pixel units or physical units? And half the time people know, half the time they don't know, I kind of have to try and just figure out which one it is. I'd really like to just write this down. So as an image analyst, I don't want to have to worry about this stuff. Let's please just write it down. And when I put my software developer hat on, that's when I think I have to worry about this stuff. Not when not when I have my image analyst hat on. Okay, cool. And in summary, many relationships are transformations, right? When you crop something, has anyone cropped something and then had to go back to the original image? And then you maybe know how you did it, but maybe you don't, and maybe your software recorded how it happened. That's great stuff. And these are some of the larger problems that I hope this specification will address, which brings us to the specification. If you go to the NGFF website and look for RFC5, you'll see the proposal is first flat support for spatial and coordinate transformations. Okay, so now a short dive into the technical stuff, but it will be very short because I'll just explain what coordinate systems and transformations are. And I'll do that by first showing you what is now in NGFF version 0.4. It has a set of axes and they're just a list of things with a name, a type, and a unit. And the only thing we added is you've given these things a name. And this is super simple but powerful because now you can refer to things by name. And if things belong to a coordinate system with the same name, you can know something about them. Like that objects in the same coordinate system can be jointly compared and analyzed. So if two images are in the same coordinate system, then you know they're like probably channels of the same multi-channel image, or maybe a segmentation of some image, or so on. And I say objects because in the future, I hope we can extend this to things like point annotation, which was remains one of my big headaches, right? And as I've alluded to, what coordinate transformations do is convert between different coordinate systems and express the relationship between different coordinate systems. And to do that, here's what version 0.4 coordinate system looks like. And it's really simple. There's a type and some parameters. And really all we are now doing is adding an input and output, which is the names of the coordinate systems that we can put in the output are, so that it knows what the relationship of which coordinate systems are. And that has some powerful results, I think. We've also added a lot more types of transformations. And this is something that we can discuss further. This is a lot, but I don't expect every implementation should have to support every type of transformation. Someone will not care about nonlinear registration, and I think it's okay for an implementation not to do nonlinear transformations. Okay. So a bunch of examples of some use cases, and with Will and Josh's help, the NGFF validator is being updated, and now you can validate any data against this proposed specification. That's really exciting. I'm going to walk through 3 examples quickly, and then we'll move on to some other stuff. So this is a 3D image registration example. And here I'm just dragging something into an experimental viewport, and it's going to open 2 images. On the right, there's going to be the target image, and on the left, and I'm going to overlay it now, you're going to see it's on the fly, figured out what the transformation is, and applied it to the moving image. So there's moving, there's target, there's moving, there's target. Another nice thing about this is that there is directionality, which I hope take it forward. We can go the other direction too. So what you're going to see now is essentially what used to be the moving image is now the target. What used to be the target is now the moving. So the transformation also knows directionality, which is really important for me and something that I've had to keep track of in my head and would love to never not have to keep track of it. Next is a lens correction. So this is meant to be like a lens distortion correction example. And what's interesting about this is it's a 2D transformation that's applied to every slice of a 3D subset. So there you're seeing this kind of like non-linear warping kind of thing that happens maybe to every plane in a 3D image. And pay attention here, because this is my favorite. Here I've registered 4 images together There's a green, a blue, a yellow, and a pink. And I've registered them pairwise, kind of like, yeah, kind of like I don't know if you prefer I kind of like the mouse for Zoom people, but. I registered yellow to blue, blue to red, red to pink. And I'd like to align them all together. And I'd like to not have to remember that this transformation goes between these two. This one goes between these two. I'd like to just say, given this collection that I've written down very carefully, hey, piece of software, I want to display all of these images in the pink images coordinate system. So that's what you're going to see here in Big Warp. The images are open and they're kind of like native coordinate systems and they're not aligned. But I'm going to point it to the collection of transformations that I've stored carefully with very well decided metadata. And I'm going to say, please display them in the pink images coordinate system. It's going to figure out which transformation or set of transformations to apply to every image. And now things are nicely aligned, and more details at the poster if you care. Okay. And that brings me to the end of the technical stuff. And I want to talk about some, I guess, community aspects of this, like what's going to happen in the future and what happened so that this proposal now exists, and maybe what are some challenges that happened along the way. I'm going to take a quick version that I think I'm going to go through a little bit quickly, because this would be a nice unmeeting topic and maybe a nice point of discussion in, I think, the version 1.0 workshop. But version 0.4 of NGFF is stable and widely used, and that's excellent. This community must make sure that whatever we call 1.0 is at least as stable, well supported, and like long-lived. And there are things that we want and use cases that we want version 1.0 to support. And I don't know, I can't tell the future, but I expect that whatever version 0.5 is today probably won't live as long as version 0.4. But I expect that whatever we decide to build on top of that, we will perhaps pin something as a, I don't know what to call it, but prototype or staging or something, because we need a community of people to really try this out. And I think the community of people that try this out, I'm calling, I guess, trailblazers, because I don't think every end user should have to deal with exactly this set of transformations that I propose now. But once the invested parties try it out, confirm that they're happy with the state of affairs, maybe we add some tweaks if we need to, maybe these tweaks aren't necessary. And we say, this is what version 1.0 will be, and this is a future that I hope will happen. Okay, now more about this in particular. So on the left, I'm showing a GitHub issue in which we collected some user stories, which are use cases that we wanted this specification to cover. And I'm looking at what Casey said the other day about local versus global problems. Because I know when I started this, I had my problems in mind, obviously. But this clearly became something larger, and it is important and good that it now supports use cases that I wasn't thinking about, and that not all of which I do day to day. This happened on GitHub, and in retrospect, this maybe isn't the best place to collect end user information. We did get a lot of useful information from this, but in retrospect, the community on GitHub is not representative of the broader community here, right? Where GitHub is good is we're collecting technical feedback. And there's a lot of technical feedback. There's like hundreds of decisions, hundreds of like little decisions that go into something like this, and a couple of big ones. And I think from my perspective, managing all of those and trying to align those decisions with what I perceive are the priorities of the community was the hardest part. So as a specific example, we had a lot of use cases that we want to support. For every use case that we support, we might have to add something to the spec, making it bigger. So a trade-off is, do we have a small, compact, simple specification, it's easy to implement, but doesn't support everything, versus a larger, potentially more complicated spec that supports more people's use case application. I tend to lean and prefer on supporting more use cases so that this is more broadly used, but not everyone will agree. So this was one of my challenges. And hackathons were a place in which I think I had my priorities or I tried to align my priorities. So at this hackathon in 2024, organized by Matt and others, this is where I think we decided on the last big decision that ended up going into the specification, and is when like a pull request in GitHub became RFC5. So this was a really useful one. As well, I attended earlier this year hackathon at the Biovision Center in Zurich, organized by Virginie and others. And it was at meetings like this that I think better reflected the community at large better than the GitHub issues, right? So I think here is where I learned more what end user prioritized than the GitHub issues. And so these kinds of meetings and this meeting, I think, are really valuable for that kind of feedback. That brings me to the end. So thanks to all these people. I'll make, I guess, one more comment, which is having a small number of really invested people, and so people and institutions that are invested. And for that, that's me and Janelia and Stefan, who is willing to have me work on this. And then a larger group of invested and committed developers who just agree on all of this stuff. And also, really importantly, a large group of users who express their both displeasure and successes for projects like this are essential for making this work. So I think I'll end. I want to give John a hug for
Going back to the proposal of, the RC come out, what is kind of timeline you're suggesting? Try it out, the proposal, we need to also give a time frame, and something kind of discuss is maybe having it instead of random time, so people like in the year slot, having this slot during the year, we say, okay, we are aiming to have proposal X, block some time for validation. Do you think that will help you in the long run? You or anybody else, but I mean, having all that in place.
Absolutely, yeah.
And you decided period of the year, like other project do, at least in spring or summer.
Something like that, I think, would help me personally, but it depends on the timeframe of everyone involved working toward the D. And I think what I need is the interested implementers who are going to be implementing the most challenging parts of the spec to implement it, because that's, I think, the limiting factor. But something that you propose, I think, would be useful.
But I agree, everything, everybody's busy, but I think if we block a time ahead, that more likely to avoid that business. I think if you announce a week late, I don't know, 3 weeks earlier, it's not enough. It's 6 months. If we have almost a rota of, and that might be to discuss at one of the Zarr call, a rota of this is when it's coming out, like almost a year in advance. We kind of see where we give targets. I think that would help moving forward.
I just want to say to you, John, and Stefan, thank you so much for taking this on. I think in the early days, so I've been in the background and whispering in Josh's ear, and Josh and I've had, I would say, fairly potent discussions about this, where I've just been saying, let's just get this, do something. And really appreciated your willingness to engage and to continue to take this forward. Speaking as just my opinion, but the problem, I think you've done a great job of talking about how, first of all, how hard, but also how general this problem is I think Stefan showed last night, it's everywhere. It's in all of the biology that we do. And that's maybe, I'll just say, I didn't think that far ahead early enough. And maybe, deciding what boundaries we're going to put on the problem. What are the things we're going to try to solve today, knowing full well that we'll leave a lot of people not yet addressed. Yeah. And so just thank you.
Appreciate it. Yeah, boundaries are. Anyone else have questions?